Hello everyone, my name is Asaf Nadler, and together with Jordan Garzon, we are presenting this talk titled Tracking Unsafe Services that are hosted by bots using IP reputation. Both Jordan and myself are data scientists and security researchers for Akamai Technologies. Our emails are listed below if you want to reach out to us after the conference. The agenda has two parts. The first part, displayed by me, will discuss the introduction and the overview of the system that we're proposing. Then I'll hand over the stage to Jordan to discuss the analysis of the system and the takeaways. So as an introduction, we know that bots are machines on the internet that are controlled by a single entity, typically called the bot herd, to deliver attacks on external services. So for instance, a bot might conduct an account takeover attack in which various known and stolen passwords are used against an external service, or conversely, issue a denial of service attacks against a set of web servers. However, while we typically think of bots as delivering attacks against external services, they can also be used to host malicious content and wait for victims to visit them. So for instance, bots may be hosting phishing campaigns for victims to visit, or drive-by attacks for victims to visit and download a malware when browsing a web page that is hosted on the bot machine. So the motivation for the system that we're proposing is to track bots on the internet that carry out malicious attacks against external web services, and then protect end users from visiting content that is hosted on the same servers hosted by the bots, to potentially protect the end users against phishing, malware, and other malicious content that may be hosted on the bot machines. So to do that, we first need to go over the concept of IP reputation. So we start with the Akamai platform, which is the largest word CDN being used to host websites related to healthcare, banking and finance, and e-commerce. The websites that are hosted on the Akamai platform are typically subject to various attacks by bots, such as distributed denial of service, account takeover, and SQL injection. Our systems at Akamai are tracking IPs that communicate with websites on the CDN, and whenever these devices are behaving in a malicious manner, they get a poor IP reputation score. So there's a single database in which each of the devices that interacts with the websites is getting a score based on its behavior, and the Akamai CDN platform is interacting with more than 1.3 billion devices per day. So for each one of those devices, we record a score to know which ones are potentially bots hosting, carrying out attacks against websites hosted on the CDN. So using the IP reputation, we are able to identify bots that are engaging in delivering external attacks, right, outbound attacks. But now we're looking at the other direction. Once we have the idea of who these bots are and we know their IP addresses, how can we protect users against visiting content hosted on these bots? So for that, we're looking at the DNS protocol. So DNS protocol is a core component of the internet, typically used to translate human memorable domain names into internet routable IP addresses. So for instance, the DNS protocol will assist in translating the domain name akamai.com to an IP address. And Akamai processes on a daily basis more than 2.2 trillion DNS requests. So whenever a user makes a DNS request to translate a specific domain name, if we know that the domain name is resolved to an IP that was previously associated with a specific bot carrying attacks against websites on the Akamai CDN, then rather than serving the DNS request, we can block that, thus saving and protecting the user from visiting content hosted on a malicious machine. So now we combine the 2 points together. We combine the DNS and the IP reputation. So as a first step, we collect the IP reputation based on bots that attack websites hosted on the Akamai CDN. And then on the DNS, we're looking for machines that are being resolved to these IPs. So these are practically the 2 steps. We're first focusing on identifying IP addresses of bots, and then as a second step, we're looking for domain names on the internet that exclusively resolve to an IP which we know is associated for a bot over a sufficiently long period of time. So at this point, I will hand over the stage to Jordan for the analysis and the takeaways of the system.
Hello everyone. Thank you, Asaf, for presenting the first part. As you understood, we're going to use 2 types of data, the data of the IP reputation plus the data of our repressive DNS, the enterprise DNS traffic. So let's dive more into the technical details of the system. First question that we're going to ask is, what malicious content is typically hosted on bots? And the second one is, what number threat we are discovering with this technique? Let's start with the data. So on one end, we have the data from IP reputation, from the CDN, from the attackers of the CDN. There we extracted 700,000 IP addresses involved in inbound attack. When I say inbound attack, it's basically the attacks coming from the hackers to the victim. For example, SQL injection, account takeover, DDoS, etc. Those are inbound attacks. In this data set, we have 3 parts. The biggest part is account takeover data. The second one is the classic web attacks, SQL injection, RFI, LFI, etc. And the last part, the tiny part, is DDoS IPs. About the second data set, we sampled 2 weeks of enterprise DNS traffic with 11 billion DNS queries a day. From those queries, we extract the domain. We ended up with 11.1 million domain. We worked second level domain because we did this analysis with only primary domain. Most of them are resolved to a single IP address. Nowadays, with the shared hosting platforms, most of the websites share their IP, meaning that the platform that hosts those websites use one IP to host several websites. Only 15% has a unique IP. Why do we need a unique IP? Because if we want to make a join between IP reputation and the IP of the domain, we need to be sure 100% that we link the good domain to the IP. Otherwise, we can create false positive. And 10% is 0.1%, is identified as outbound attack. What is outbound attack? Is basically the opposite of inbound, meaning that this time the victim is reaching to the hackers. For example, in the case of phishing website, the users browse the phishing website. So again, we have 3 parts. So from those 10K domains, we have 3 parts. We have phishing campaigns, malware hosting websites, and website used for CNC communication. If we summarize, we have the world of IP addresses with 3.7 billion IP addresses, IPv4. We have on one end the dataset of IP reputation with more than 700,000 IP addresses involved in attacks. The second dataset is composed of DNS traffic, and there we extract only malicious domain, so 10K domain, as well as 10K IP, because those domains have a unique IP. And if we make the cross, we find that only 95 IP addresses. It looks small, but if we take a look closer, we see that it's basically 1%. 1% of all malicious contents, meaning outbound attacks, phishing website, malware hosting website, etc., are also involved in inbound attack. So when you browse a phishing website, you have a chance over hundreds to be in the same place of a SQL injection, for example. Just a small remark. We use only label data, of course, to not make mistakes. So we get 1%, but in the wild, we expect a higher correlation. We can maybe reach 2-3% of the intersection. Now let's take a look at the location of those IP. Most of them are located in the Asia, China, Hong Kong, Vietnam, Singapore, of course in US because it's a big country, but we've been running this project over a few months already and most of the IP are there. And you'll see why at the conclusion it's important to notice that. Now, if we want to cross the type of the inbound with the type of the outbound, we see that the highest correlation happens between phishing malwares and web attack. You have no chance to go to browse a phishing website and be on the same place, let's say, of DDoS, or same for malware and DDoS. But you have a high chance to be at the same place, in the same place of SQL injection, RFI, XSS, etc. Even though web attack, we don't have a big data set of web attack, still the highest correlation happened there. Now about our detection. Is it a non-issue among the cyber community? So again, we've been running this project over a few months, and every day we detect 500 domains that we block. Among those domains, 80% is not detected by any engine on VeriStotal. I just want to remind you that those domains are linked to malicious activity. So they are for sure suspicious, even malicious. We should not browse there. And still, only 20% are detected. Also, we are providing our customers with 8K suspicious domain so they can block them if they want. Now let's take a look at two examples. The first one is a group of websites that we detected in October issuing account takeover against a very popular French streaming platform. Let's take a look at those websites. We picked only 5 of them, but there is a big list. I leave you a few seconds to look at it. You see they are based on the same templates. You see the IPs. This is the IPs provided by the IP reputation. The domain. This is the domain we found with our DNS data. And this is why we blocked them now. Also, some of them are detected by VeriStotal. They are all located on the same autonomous system. They target all the same targets. And the question that I want to ask you now, do you want to put your email there? Submit your application now. Do you want to put it? We don't recommend it. Why? Because those are websites under attacker controls that do not contain malwares, they do not contain phishing pages, but still they are under attacker controls. Let's see the second one. It's basically a classic malicious website. So we've seen the end of October attacks coming from the IP 51.83, etc., issuing SQL injection, WordPress scanning vulnerability on several customers. Our algorithm resolved it to the domain research3d.com. It was also a newly registered domain, and this is how it looks. On VT, it's pretty easy to see that it is malicious. We see 9 detections on these domains, and it's a distributor of Emotet malwares with document files. So this is basically what happened only on 20% of the data. classic malicious website. So about the conclusion, more than 1% of malicious websites are involved in web attack. It doesn't happen a lot, but the majority are hosted on Asia and also on US. The highest correlation happened between phishing malwares and web attack, meaning when you go to phishing or malware website, you have a high chance to be on the same place of web attack, SQL injection, XSS, LFI, but not DDoS, for example. We are protecting our users with 500 domains a day, plus 8K suspicious domain. I underline again that 80% of those domains, the 500, are not detected by any engine on VT, even though they are definitely linked to malicious activity. But the future work, we want to convert those suspicious domains, the 8K, to non-domain with metadata, geolocation, autonomous system, website templates. Those are features maybe for a machine learning model. When it's possible, we can maybe enrich the IP reputation with the IP of our domain. In our case, we use IP reputation to enrich our intelligence of domain. Also, we are thinking about releasing a full detailed view of the algorithm so it can benefit the community. Thank you very much. Q&A. I hope you enjoyed.